Hey guys, so today we're going to be going through the whole of IGCSE sequences in this video. So let's get started. So first of all, you need to know how to describe patterns. So basically they give you a sequence and you have to describe it in words. So what you have to do is, first of all, but for example, this first sequence over here, it goes 1, 2, 3, and 4, right? So you can see a trend here, right? Each number is increasing by 1. So that means you pretty much have to say add 1 to the previous number. And yeah, that's all that you have to say for that one. And yeah, so the second one here is a little trickier than the last one, but it's actually pretty easy. So what you can see is the first number is 2, and the second number is 4, which is 2 times 2, and 8 is 2 times 4, and 16 is 2 times 8. So what you can see is you multiply the previous number by 2. So pretty much what you say is multiply the previous number by 2. And that's it for the second one. And now for the third one, it's a little more complex than the last two, but here we go. So what you can see here is to get to 3 from 1, you multiply 1 by 2 and you add 1, right? So if you multiply 1 by 2 and you add 1, you get 3. And if you multiply 3 by 2 and you add 1, you get 7. And if you multiply 7 by 2 and you add 1, you get 15. So that means multiplying by 2 and adding by 1 works. The sequence generally you should be able to get it with trial and error with the describing the patterns part. Yeah, so pretty much what you say is multiply the previous number by 2 and add 1. Alright, so the next one is linear sequences. So that means these are sequences with an nth term. So what this means is that instead of describing sequences like you did in the last part, you pretty much have to come up with the equation of the sequence. So what you do here is you start off with the sequence as 2, 3, 4, and 5. You write it out like that, and you can see that to get to 3 from 2, you add 1. To get to 4 from 3, you add 1. And to get to 5 from 4, you add 1. So that means this is going to be your nth term. So that means the sequence would be n plus something. And the way to get this n plus something, this plus something, is you pretty much find the number before the first term. So to get here, you have to subtract 1, right? Because you're adding 1 to go to the right. So to go to the left, you subtract 1. So that means it'll be 1. So that means the equation would be n plus 1. Alright, so the second one, you pretty much do the same thing. So you say 4, 6, 8, 10, right? And you do the same thing. So to get to 6 from 4, you add 2. 6 to 8, you add 2. 8 to 10, you add 2. And that's what your n is going to be. So you see this 2, you multiply that by n. So you say 2n plus something. We need to find the something, so we subtract 2. because we add 2 to go to the right. So to go to the left, you subtract 2. So 4 minus 2 is 2 by subtracting 2. So that means the equation would be 2n plus 2. There we go. Alright, so this third one, you pretty much do the same thing again. So you go minus 3, minus 5, minus 7, minus 9. And what can you see here? To get to negative 5 from negative 3, you subtract 2, right? And then negative 5 to negative 7, you subtract 2 again. And from negative 7 to negative 9, you subtract 2 again. And that means that it would be negative 2n plus something, right? So that means if you go to the right, you subtract 2, right? But we're going to the left, so you do the opposite, so you add 2. So negative 3 adding 2 will give you negative 1, and that will be your constant. So it will be negative 2n plus negative 1. So that means, simplifying it, would be negative 2 minus 1. Alright, so that's linear sequences. Now the last thing we need to go through is quadratic sequences. So here you kind of do what you did with linear sequences, but it's a little more complicated. So first of all, we write our sequence out like this: 3, 6, 11, 18. And to get from 3 to 6, you add 3, right? So you add 3, then from 6 to 11 you add 5, and from 11 to 18 you add 7. As you can see, it's not increasing by the same amount, which shows you that it's not a linear sequence. So that means you have to do this again with your 3, your 5, and the 7. So you take your 3, to get to 5, you add 2. And to get from 5 to 7, you add 2. And you can see now these two numbers are the same, right? Plus 2 and plus 2. And this means that this would be your n squared. So if it was plus 2, it would just be n squared. And if it was, let's say, plus 4, you say 2n squared. So yeah, you go by multiples of 2. So now we have our n squared, but we don't have the n or the constant, right? So that means we write out our original sequence like this: 3, 6, 11, and 18. And we know that it's a quadratic sequence of n squared. So that means under the original sequence, we write the sequence of n squared. So we write 1, 4, 9, and 16, which is basically 1 squared, 2 squared, 3 squared, and 4 squared. And what we do now is we subtract. So now that gives us 2, 2, 2, and 2. So that means this new sequence is just 2, right? So that means the quadratic sequence for this one is just n squared plus 2, right? Alright, so the next one would be negative 1, 5, 15, 29. Alright, so what you do now is the same thing that you did in the above sequence. So from negative 1 to 5, you add 6, right? And from 5 to 15, you add 10. And from 15 to 29, you add 14. And we go another layer downwards. So from 6 to 10, you add 4. And from 10 to 14, you add 4. So now you can see 4 is just 2 times 2, right? So that means it would be 2 times n squared, because plus 2 would be n squared, and plus 4 is 2 times 2. so you have your 2n squared, but you don't know the n and the constant. So you write the original sequence, so -1, 5, 15, and 29. And then you write the sequence for 2n squared. So 2 times 1 squared would be 1, 2 times 2 squared would be 8, 2 times 3 squared, which is 2 times 9, is 18, and 2 times 4 squared would be 32. And basically you subtract them again, and you should get -3, -3, -3, -3. So that means that your sequence for the second one would be 2n squared minus 3, which basically means that the n would be 0. So 2n squared plus 0n minus 3, pretty much. But because it's 0n, you don't write the n. Alright, so the last one here would be, you write it out just as normal, 6, 17, 34, 57, right? So to get to 17 from 6, you get 11, you add 11, and then from 17 to 34, you add 17, and from 34 to 57, you add, that should be 23. And then you go another layer, so from 11 to 17, you add 6, and from 17 to 23, you add 6 again. Right, so that means 6 is 3 times 2, right? So that means the n squared part would be 3n squared, which is 3 times 2. Yeah, so you write your original 6, 17, 34, 57, and you write your sequence for 3n squared, which would be 3 times 1 squared would be 3, 3 times 2 squared, which is 3 times 4 is 12, 3 times 3 squared would be 27, and 3 times 4 squared would be 48. And what you get now, if you subtract, is 3, 5, 7, and 9, right? So unlike the last two, it wasn't just a constant number. Now it's 3, 5, 7, and 9. So now you go back to what you learned in linear sequences and you solve this. So what you do now is from 3 to 5, you add 2. From 5 to 7, you add 2. 7 to 9, you add 2. That means it's 2n, which is your n, 2n, and then plus something, right? So to the right, towards the right, you add 2. Towards the left, you do the opposite, so you subtract 2, and that gives you 1. So that means this something is 1. And then you put everything together, and what it should give you for the whole sequence is 3n squared plus 2n plus 1. And that's your quadratic sequence for the last one. And that's pretty much everything on sequences that you need to know. Thank you.